So this problem is chapter 3, number 19, which is another motion on the ramp problem. It reads, a piano has been pushed to the top of the ramp at the back of a moving van. The workers think it is safe, but as they walk away, it begins to roll down the ramp. If the back of the truck is 1 meter above the ground and the ramp is inclined at 20 degrees, how much time do the workers have to get to the piano before it reaches the bottom of the ramp? So the first thing we'll always do is write down everything that we know. So we know that the height of the ramp is going to be equal to 1 meter. And we know that the angle of the ramp is going to be equal to 20 degrees. And they would like to know what is the time. First things first, always draw a picture. We get that this height is 1 meter and that this angle is 20 degrees. So a few things I would like to know. I would like to know how quickly is it going to accelerate, because it's starting from rest, so the acceleration is what's going to get this thing going. And the next thing I want to know is how far is it actually going to travel down this ramp. I'm just going to call that D. So I'll first attack the distance. We know that we're going to use sine because we have an angle and we have the opposite and we need the hypotenuse. So we get that the sine of 20 is going to be equal to 1 over D. Or D is equal to 1 over the sine of 20. Or D is going to be equal to 2.92 meters. So now we know that, 2.92 meters. Next thing we'll need to know is that acceleration. So acceleration is equal to G, oops, get rid of that, sine theta, or 9.8 times the sine of 20. So our acceleration, when we do that out, is going to be equal to 3.35 meters per second squared. So now that we have this distance and we have this acceleration, we can find the time. So just by using x equals x sub o plus v sub o x t plus 1/2 a t squared, where our initial distance is going to be 0 and our initial speed is 0, because we're assuming that this is going to be our starting point and that we're starting from rest. So we're left with 2.92 is equal to 1/2 3.35 times t squared. So that t squared is going to be equal to 1.74. Take the square root of those two things, and we find that the time it takes is 1.32 seconds. So that was chapter 3, question number 19.